Hello civil engineers, I'm Akshay Kamath and I'm your corporate trainer for Reinforced Training Institute for Civil Engineers. In this video, we will see how to understand a residential building and we'll also try to understand how to place the column, and after that we'll try to model the same building with the help of Etab software. So this is a plan of a house building. You can see a bedroom is here, then we have a living or a dining room here. From here we can make an entry to a kitchen. Then we have a puja room here. There's a bathroom here and a water closet here. So whenever we get a plan, the first thing is to decide the column location and the orientation of the column. So let us say this is a G+2 building. So a 9-inch by 15-inch column is sufficient for us so that it can take the load. So we'll try with a 9-inch by 15-inch column. I've already drawn a column here. So we'll try to keep the column wherever it is necessary. The first rule is that wherever we have a corners, we need to keep the column, and after that we'll try to keep wherever it is necessary. So every 5 meter you can keep the column, and then we can decide after the analysis whether the location and the orientation of the column is sufficient enough to take care of the load. Just in case if it fails, we'll try to increase the size of a column, and even after that if it fails, we can try to add more columns to that. So I've already done a column here. So I'll select on this. I'll copy it from here. Yeah. And we'll try to place it wherever it is required now. So let us, yeah. So let us say I want to keep one column here. Since it's a corner portion, I'll keep a column here. Yeah. Let me make it again. Yeah. So this is the first point. Then again, I have another corner here. Let me place it here as well. And after that, there's one more corner here, so I'm going to place it here. Right now I'm taking the orientation in this way. Later if you want, we can try to change the orientation of this column. Then I have another column here. I'll try to place another column in this location. Yeah, so almost all the corners have done it. Now we'll try to say wherever it is required. So now directly I cannot have only two columns here, right? So I need to add another one column in between this portion. So let me try to add one more column somewhere here. Yeah, I'll add one more column here. And the basic practice is that try to align the column in the same direction. Let us say I've kept one column here. The next column, it doesn't make sense to keep it here. So I'll try to keep it in the same location. Let me keep one more column here. Let me try to zoom in and keep it. And then you can keep another column here. Yeah. So once this is done, again, this, if I don't keep another column here, this entire span, what you can see, one column is here, this is a second column here, it becomes a very large span. So in order to cut that, what we can do is we can insert one more column in between this. So the better practice is try to keep one more column somewhere here. I'll keep one more column here. Then we can have a one more column somewhere here, because it's in the same same alignment. This alignment has to be same so that the load transfer will happen easily. Yeah, so I feel this is enough now. So we have provided 1 2 3 4 5 6 7 8 9 10 11 10 11. I need to keep one more column here. I missed it. Let me do it again. Yeah, so this is sufficient. Now the question that comes in our mind, all the columns are oriented in this way, right? So this is how we are oriented the column. So the better practice is always try to see, we have missed one more column here. Let me do it. Yeah. So the better practice is try to see whichever is the longer span. In that span, we need to orient the larger depth of the column. For example, let me keep one more column here. Yeah, I'll take it this column. Let me keep one more column somewhere here. Yeah. So if I try to keep a column in this way, what is going to happen? Yeah. Let me try to do this. So the better, let me add one more column somewhere here. So since I'm adding a one more column here, what has happened? This column has created an offset in this particular area, right? So it doesn't look good from aesthetic point of view. So what we can do is we can try to orient this column now, right? So what I'm going to do, instead of this, let me delete this column again. So I'll take the horizontal column so that there is no offset created. And let me try to keep it the column in this way. Yeah, done. So this is not creating any offset because this will be flush with the wall. Now if you look at the columns, they all are good. Again, this column, if you look at this column, you can keep either in a horizontal way or in the vertical way. So, but we need to understand one thing. The thing is that we have to see what is which is a larger span. Now, if I try to measure the distance from here to here, it comes out to be 15 feet 9 inches. And let me try to see the distance from here. I'm taking some random values, not exactly from the center. Yeah, so this comes out to be 17 feet. Now we need to see whichever is a larger depth, whichever is a larger longer direction, parallel to that we have to keep the orientation of the column. So this is 15 feet 9 inch and 17 feet 11 and a half inch. So by default, it's understood to that this is a longer span. So since this is a longer span, it's always a good practice that whatever is the depth of your column, try to put it in this way. That instead of putting in this way, let me try to change the orientation of the column. I'll delete the column and let me keep the orientation of the column in the other direction. So I'll keep the column something like this. So now what has happened here, since this length is larger 17 feet, I need to keep the longer direction parallel to this. You can see this is longer direction because we have studied this during our engineering days. Moment of inertia is equal to BD cube by 12. That if the depth is more, it can resist more moment and it can have good capacity, right? So that is why it's always a good practice. If you have a longer span in this way, try to orient the column along that direction. Sometimes what happens, even though you need to keep this column in the longer direction, the architect will not allow you, maybe due to the offset problem. In that case, we don't have any option but to go with the same orientation like this. But if you have a privilege to do, if you have a privilege to orient the column on the other side, it's always a good practice. Try to delete the column from here, and let me delete it again. And I'll orient the column in the other way around. So this is a depth, right? So the larger depth will be oriented along the longer span. Yeah, I'll keep it in this way. Yeah, it's okay, fine. So I'm keeping it in this way. So what has happened now, the longer direction is in this way. So this is a good way of orienting the column. Yeah. So once this is done, the next practice is to select all the columns here. I'll select all the column, select similar. So all the columns will be selected and I'll copy the selection and I'll try to move all this column from here. Yeah. So if I try to make all the columns here, so what has happened? I got all the columns here. So this will act as a base for my modeling in the Etabs. So already I've created a model for this. So we'll go back to the Etab software. So I'll take you to the Etab software. So this is how I created the model. So when we join the classes, we'll be able to understand how these things has to be done. So let us say this is a model what I've created. So once the model has been created, we need to tell to Etabs that what is the material that we are going to use, that is which grade of concrete I'm going to use, whether it is M15 grade. Anyhow, M15 we don't use in the RCC structure, so we start from M20. So M20, or whether it is M25 grade of concrete. If you're going for a high rise structure, in that case the code recommends you to use minimum M30 grade of a concrete. But since this is a residential project, we are making use of M20 grade of a concrete, and that is sufficient enough to take care of the load. So what I'm going to do, I'll directly try to explain the Etabs tools, right? So I'll go to define option. We'll go to the material properties. So I'm going to tell Etabs that I need to use M20 grade of concrete. So by default, all this has been created, but anyhow, we'll try to create a new one now. So I'll go to the add new material option. So the moment I go to add new material option, the Etabs is going to ask me which region you belong to, what kind of material you need to use. Since we are staying in India, I'll make use of the Indian code book and I'll say I'm in India. So material type, I want to make use of concrete. So we have a lot of materials here. If you want to make use of a steel structure, then you can make use of steel here. If you want to put up a RCC, like if you want to make use of a concrete, you can make use of concrete here. Other than that, if you want to make use of this rebar, is called as steel that we use there, right? This is the steel what we use in the construction industry. These are the steel for the steel structure. These are the normal rebar what we call, that is called as reinforcement bar. If you're making use of a pre-stressed structures, that is called as tendons, you can even make use of that. But for time being, we'll take concrete, and then the standard is Indian. Let us say I want to make use of M20 grade of a concrete, and I'll select OK button. then all these properties will pop up. Anya will not try to get into this. We'll try to understand all these things once we join the course. Yeah, and then I'll directly hit on the OK button. So all these things are based on the strength of materials things what we have studied. That is modulus of elasticity, what is Poisson's ratio, what is shear modulus, what is the unit weight of a concrete. All those things, by default it's going to come here. We don't have issues with that. And you can see the directional symmetry type isotropic, right? So all these things we studied during our strength of materials. We have done the assumptions that the material is isotropic and homogeneous. That is the reason you can say isotropic here. So I'll click on OK, and I'll click on OK. So what has happened? You can see M20 grade has already come here, right? In the same way, I need to tell Etabs what kind of rebar I'm going to use, whether I'm using Fe415 or Fe500 grade or Fe550 grade of a rebar. So again, I'll go to add new material. I'll go to India. It's the same thing. So instead of concrete, this time I'll go for rebar. If I go to rebar, rebar stands for reinforcement bar. So I'm getting 3-4 options here. So mild grade we do mild steel we don't use these days, and even HYSD grade 4 and 5 is not available these days. Whatever is available is HYSD. HYSD stand for high yield strength deform bars, and grade 500 is the tensile strength of that rebar. So let us say I'm making use of HYSD grade 500, and I'll click on OK button. The moment I hit on OK button, again another unit window pops up. Again, it's the same thing written here. Whatever we studied in strength of materials, the same thing has come here. Like what is the direction you are applying? It's a uniaxial load what you are applying. What is the unit weight of a steel? It comes out to be 7850 kg per cubic meter. That is why you can see here 7849. If you're putting in terms of kilonewton, it comes out to be 76. And the modulus of elasticity, we have already seen that 2 into 10 to the power of 5 is what we had taken during our engineering days. That is the reason you can see it's written here. And the thermal expansion is also same. Then you have to click on OK button, and by default what has happened, your grade has come here. That's it. Now Etabs has understood that we are making use of M20 grade and HYSD 500 grade of a rebar. The next, once this thing is done, the next thing is we have to define the beam sizes and the column sizes. So it's a trial and error method. So we cannot directly say that whatever beam and column sizes we are going to define, that is going to pass. So based on experience and the usual practice, what we try to do is a column 9 inch by 15 inch is enough if you're constructing a small G+1 or G+2 building. And for the beam, usually what we try to do is 9 inch and like let us say 230 mm by 300 mm or 230 mm by 450 mm is the usual size of a beam that we try to go with. So 230 comes out to be 9 inches, and the brick that is available is also 9 inches, so that it is easy for us to flash. I mean, the wall and the beam offset will not come out, so that everything will look nice. So that is the reason we go with 230 as a minimum dimension for the beam. So what I'm going to do now, I'll go to define, I'll go to the section properties, and Etabs considers column and beam has a frame element, that is a line element. That is the reason I go to the frame sections. And other than that, if you want tendon section, this usually comes in pre-stressed concrete, but we're not doing all those things as of now. We'll go to the frame sections, and by default all the column properties and beam properties have been put up here, but we'll try to add some new properties. So what I'm going to do, if you want to delete all these properties, we can go to the delete multiple properties option and try to drag all the things from here. Yeah, and try to hit delete selected frame options and click on OK. So some of the properties will get deleted, but we'll try to add a new property from here. Go to the option called add new properties, and now Etabs is going to ask you what kind of property you want to prepare, whether you want to prepare a concrete section, whether you want to prepare a steel section, whether you want to make a steel composite or not. So by default, it's a very basic thing what we are doing. So we'll go with a concrete, and we'll say we are going to make use of a concrete rectangular section. If you have a circular columns, in that case you can make use of the circular section, but for time being we'll make use of a rectangular sections. And once that is done, so another window pops up here. So you need to tell Etabs what is the size you're using. So let us consider I'm using a 230 by 300 grade of a 230 by 300 section of my beam. So I'll write it here beam, and I'll give a hyphen here, and let us say 230 by 300 mm is the size of my beam. So it's going to ask you what is the material. So already we have defined it to the Etabs that I'm going to make use of M20 grade of a concrete. So you can click here M20. Let us say if you want to make use of M25, you can click on M25 here. Now the question that comes in mind, why other options are coming? So when we try to define the rebar, in that case we can make use of Fe500, but since it's a concrete property, we are going to make use of M20 grade. right? And M stands for mix, and 20 is a characteristics compressive strength of that particular concrete. And rest all things we are not concerned with all these things. Now this name is for our understanding. The moment I enter 230 by 300, it doesn't mean that Etabs is going to take the size. This is just for our understanding. Whatever Etabs understand is from here. So here we need to change the size of the beam and the whatever other properties. Now what is the depth of this beam? 300 is the depth and 230 is the width of that. So you have to come here and enter 300. So it is in mm, and the width is 230 what I've given. So click on this and put 230 here, right? So once this is done, we have to go to the modify or the show rebar option. So Etabs doesn't understand whether you're giving a column or a beam. So what we need to do here, since we are giving a input for the beam, I have to click on M3. M3 stands for moment 3 design, that is it will design for the flexure. Now coming to the longitudinal bar and the confinement bar. So usually the longitudinal bar what we use is FE500 here, which we have already defined there. And confinement we can, the IS 456 2000 code book says that you cannot use the rebar grade more than 4 greater than 415 newton per mm square. But nowadays 415 is not available in the market. So what we can do is we can try to input fe 415 here itself, and in the site we provide 500 newton per mm square grade of a steel. That doesn't make any problem. Now coming to the top bar and the bottom bar, this is about the cover that we try to give in the beam. For time being I'm taking it as 25 for the beam on both the top and the bottom, right? And I'm going to hit a enter button here. So this comes for the ductile detailing. We are not doing the ductile detailing as of now. Just click on 25 25, click on hit OK button, and then you click on the OK button. So what has happened, the whatever name I have given, right, B is equal to 230 by 300, that has come here. Similarly you can try to do it for column as well. I'll quickly try to do it for column as well. So I'm giving a name for the column as C, and let us say I'm making use of 300 by 450 mm size of a column. Again, it's a trial and error process. I'll try to define 2 3 different sizes of the column, and I'll try to assign it, and I'll try to run the model. And if everything is good, the Etabs model will give us the correct result. All the columns will pass, and then we have to try to optimize that. If it fails, then we have to try to increase the depth of the column. Usually we don't try to increase the breadth of the column, because we want our breadth of the column to get flush with the wall. That is the reason usual practice is that we keep 230 by 300 or 230 by 450 or 230 by 600 mm sizes of the column. Yeah. So once this is done, again come into the material, it's a M20, and then again, as I mentioned, it has to be 450 the depth of my column, and the width of my column is 300. Again go to the reinforcement here. So now what happens, since it's a column, by default Etab is taking this as column. The longitudinal will become HYSD 500, confinement will try to keep it as FE4 and 5. Now other than that, the clear cover for the column will be 40, and these things it's not required for us, because we are going to design it. We are not going to check the model, we are going to design it. So that is the reason you can see reinforcement to be designed given here. I click on OK now. So once this is done, I'll click on OK again. So what has happened, the same property has come here. That's it. Yeah, let me save this. Yeah, so once these things are done, Etabs knows that we have to make use of this particular column size and beams. Now I'll try to add some columns here. Already I've done it. Let me delete it again and try to do it again. Yeah. Yeah. Now let us say in these three portions, 1, 2, and 3, I need to add column. So we have a lot of tools here. So I'll go to the column option. You can see an option here, quick draw columns. I'll click on that. The moment I click on that, the Etabs is going to ask me what is the size of the column that you want to choose. Now we know that already I've decided the column size as 300 by 450. I have to go and search here. So yeah, you can see a 230 by 450 column has come here, but we had given M20 grade of concrete. We'll try to search that as well. Okay, for time being, let me consider this, that I'm making use of 300 by 450 mm size of a column. I'll click on that. The moment I click on that, a small window you can see, right? A column has come here. So I'm going to place my column here. Then wherever you have a grid intersection, there you need to keep your columns. I'm going to keep my column here as well. I'm going to keep my column here as well. So in this way, we need to look at the architectural drawing, right? Blindly, we cannot place the column. Go back to the architectural drawing, check wherever the columns are put. You can see 1, 2, 3 columns have been put up, right? And the same thing we are going to model it in the Etabs. Now randomly I'm going to place a columns here. So let us say I want to place one more column somewhere here. I'm going to place it in this way. I'm going to place one more column here, and let me say I want to place one more column here. So in this way I'm going to place all the columns. Now we need to understand one more thing. If you go back to the drawing here, you can see the orientation of the column, right? This is vertical, but this column is horizontal, and this column is vertical. But if you look at our Etabs model, what I have done, I've placed this as horizontal, even this is horizontal, and this is horizontal, but this column should have been vertical. So what is the best way to do that? The simple way to do that is click on the column, go to the assign option, go to the frame element. Since column and beams are frame element, we have to go to the frame. There's something called local axis, right? We'll go back to the local axis. So here it is 0 degree. Now I want to rotate that, right? So I'll make it as 90 degree, and I'm going to hit a apply button. So the what has happened now, this is a local axis, what you can see. We'll not try to get into this. I'll click on this. So can you see that? You can appreciate this now. So the column has been changed and the orientation has changed, right? So in this way you have to place the columns. Once the columns have been placed, the next task is to place the beams. So I already have placed the beams. Let me delete those beams and do it again. Yeah, yeah. So there's an option called beam here. I'll go to the beam option. Again, the Etabs is going to ask me what is the section of a beam that you want to take. So I'm going to tell Etabs that I'm making use of 230 by 300 size of a beam. I'll click on that. And the main is that you have to check for the center point. From this center to this center is what I need to place my beams. From here to here, I need to place my beams. From here to here, I need to place my beams. Let me do it in this way. Yeah. Similarly, I want to place a beam from here to here, right? And similarly, let us place a beam from here to here. Again, while placing a beam, we should look into the AutoCAD drawing and see wherever the beams have been given, right? So you can see a beam layout done by me. Yeah, so this is how a beam layout has been done. So you have to look into this, and the same thing has to be modeled in the Etab so that we get a correct analysis result. So in this way, I'm going to model the beams wherever it is required, right? So once the beams have been modeled, the next thing is about the slab. So slab we are not decided it. So again, I'll go to the define option. I'll go to the section properties. I'll go to the slab sections. By default, the slab sections have been done. One whether I'll quickly get into this. So you have to tell Etabs whether it's a one-way slab or two-way slab and all, right? And you have to, and there are other options like what is shell thin, shell thick, membrane and all. We'll try to understand all those things once you enroll in the courses. And let us, for time being, I'm considering some beam, and I'll quickly try to teach you how to draw it. So this is a quick floor or wall option. I'll click on this, and you should be very careful on drawing a slabs. So whatever is a joint you're getting from here, you have to drag it, try to joint here as well, try to join here as well, try to join here as well, and try to join here as well. So what has happened? A slab has come, right? Similarly, you have to try to do it for all the models. Wherever the slab is required, you have to do that. So I'm going to show you a 3D model of this. I'll click on the 3D option. Yeah, by default this has come. I've already done it. So in this way, we try to model all the Etabs model, whatever is there in the plan. And once this is done, we have to try to apply the loads and all. So applying a load, let me quickly go to one of the floor and show you how to apply a load. Let us say this is a slab what I have, and I need to apply a floor finish load of 1.5 kilonewton. And let us say this is a bedroom. So in the bedroom, we take 2 kilonewton per square meter as a live load. So I click on this. I'll go to the assign option. I'll go to the shell load because slabs are considered as a shell element. I'll go to the shell. I'll go to the uniform option. Now you can see a dead option live and a SIDL has come. So let us say I'm taking SDL stand for superimposed dead load, and let us say I'm adding 1.5 kilonewton as a floor finish. The moment I hit apply here, what you can see, you're applying a 1.5 floor finish load. Similarly, I'll go to the option called PS, that is the previous selection. So again, the slab will be selected. Go to the live option, and now let us say I'm applying a 2 kilonewton live load here. So I'll click on apply. So 2 kilonewton of live load has come. So even that 1.5 remains here since you are applying it in a different case. That is why you can see only live load here. So in this way, you need to apply all the live loads, the dead loads, the SIDL loads, the loads on the beams, the wall load and all. And once everything is done, I'll try to run the model here. So once the model is running, what the model is trying to do, it's doing the structural analysis, whatever we studied during our engineering days, right? So it tries to do everything, the structure analysis. It will try to find the bending moment, the shear forces and all. So again, I'll go to the design option, concrete frame design, and I'll tell we have to go to the option called view or revise preference. So here we have to say to the Etabs that make use of Indian Standard Codebook IS 456 2000, and based on that, it is going to design us all the elements. I'll go to the concrete frame design again. I'll go to the start design check. So now what Etabs is doing, Etabs is going to design everything, that it's going to tell whether the column sizes and the beam sizes what you have given, that is sufficient enough to take care of the load or not. So we'll try to see that. I'll go to the plinth floor now. So what has happened? See, one thing we need to understand. If the color is coming pink, it means all the columns have been passed and beams have been passed. Let us say if the color is coming in the red, that means the whatever sizes we are provided, that is not sufficient enough to take care of the load. We need to increase the size. Now you can see it here, right? So all these columns have been passed. Whatever is pink in color, every column have been passed. But you can see here, it's a red in color. That means whatever column sizes we have given here, that is not able to take the load coming on that. So what is the option left for us? We need to increase the size of the column, right? So in this way, we need to do a trial and error method. You can see here, right? Even the columns are failing in this portion. You can see few columns are passing, that is pink in color, and few columns are failing, that is red in color. So as a structural consultant, what I need to do, I need to revise my sections, right? So what I'm going to do, I'm instead of the size whatever I've given, I'll try to increase the size of that, and then again I'll try to run the model. Yeah. So in this way, we need to understand these things and we have to design it. Here, all your columns are passing because it's in the terrace portion. In the terrace portion, you hardly have any live loads. You have 0.75 or 1.5 live load, and your floor finish will be there. So you don't have much load coming here. Usually the column fails in the lower portion only because it has to take the load of all the structure that is above that. That is why you can see beams are failing here and few columns are failing even in this portion. Yeah. So once this is done, we have to check the bending moment of this. There's an option called here to check the bending moment, display frame, pier or spandrel link forces. I'll click on that. So, and I have to check it for the dead load and the live load combination. Let me take all these things you'll be understanding once you enroll in the courses. One point, these are the load combinations what I'm taking. So let me try to check it for moment 3.3. I'm going to apply for moment 3.3. So let me go to the top portion somewhere. Yeah. So you can now, whatever we studied during our engineering days, that is the negative bending moment and the positive bending moment, the sagging bending moment, you can try to see it. Let me try to click on one of the beam and I'll try to show it. Now you can see it here, right? So this is the end portion. So you have a negative bending moment here, you have a sagging bending moment here, and you have a negative bending moment here. And this is a shear force variation for that. So in this way, we try to see what is the bending moment coming here. And for that, we try to design the steel that is required. Similarly, we'll try to see one more thing here. I'll try to design concrete frame design, start design check. Now you can see here, these are the area of steel that is required. You can see 341 mm square, 0, 106 mm square, 203 mm square, 352, 195. All these are the area of the steel that is required. We have to manually note down all these things. And then what we try to do is we try to find the what is the steel that is required. So if I go back to the AutoCAD model, I'll show it here how those things have to be worked out. Yeah. So in that, after that, once all those things are done, we have to do a table something like this. This is for the footing. One we will have to individually try to do what is the size of the footing that is coming, what is the depth of the footing that is coming, what kind of diameter of a bar has to be used in that way, and look at the column number, whatever column we had given there. We need to try to group the columns, and this is how we try to make a detailed schedule of that. So if you're working as a site engineer, you're going to get all these drawings, but you should be knowing how these things are coming. So these things comes with the help of a Etab software. We try to design all these things. Yeah. I'll go back to the Etabs model. I hope this is understood up to here. I'll quickly show you how the footing reactions are worked out. I'll go to the base portion. These are my footing supports what I've given. I'll go to the option called display support reactions. So always footings sizes will be checked for the unservice combination. So I'm going for dead load plus live load combinations. I'll apply, hit OK button. So all these forces, what you can see here, right? 662 kilonewton, 903 kilonewton, 5. All these are the load that is coming on the footing. Now we need to do the grouping of a footing. Let us say we have 10 or 15 footings here. So as a structural consultant, I don't try to give you 15 different footings. If you go back to the AutoCAD drawing, you see here how many footings have been given here. Hardly you have Yeah, 5 footings, right? F1, F2, F3, F4, and F5. So in this way we try to do that. We'll quickly get into that and see that. Now let us say these are the different sizes, these are the different load that is coming on the footing. So what I try to do, I'll try to do the grouping of a footing. Let us say Fz is a vertical reaction, that is a vertical force that is coming on the footing. So this is 457 kilonewton and this is 449 kilonewton. So what I try to do, instead of taking this as an individual footing and this as an individual footing, I'll try to combine this. I'll say 449 and 457 are very close to each other, and I'll design this both the foundation as a one foundation. Let me, what I'm trying to tell is, let us say this and this will be a one footing, and I'm going to give a name as F1, and this is 449 and this is 457. So out of this, whichever is a larger force, that is 457 is larger in comparison to 449, and instead of taking 457, I'll round it off to 460 kilonewton, right? So then we have our Excel sheets ready with us. I'll take you to one of the Excel sheet. So this is the Excel sheet what I have. So whatever is the load coming, right, I'll input that load here, that is 460 kilonewton. The moment I apply 460 kilonewton, the Excel is going to do the calculation for me, and it's going to tell whether for that force, whatever size of the column and whatever size of a footing I'm giving, whether it is safe enough to take care of the load or not. Now observe here, the footing size required is 2.25 square meter, but how much I'm giving? I'm giving a 3 meter of a footing. So my length is 2 meter and my breadth is 1.5 meter. Now instead of taking it as 2 meter, let me do it as 1.5 meter. So what has happened? I'm getting a warning from a Excel sheet that change the footing dimension. Why? Because I need to give more area that is required. Your area required is 2.25 and I'm providing an area of 2.25. So this is going to fail. That is the reason what I try to do. I try to make a trial and error here. So instead of 1.5, let me do it as 2 meter. So that is okay. You are giving a length of 2 meter. 2 meter comes out to be 6 feet. And this is breadth is 1.5 meter. Now you are getting an option called footing size is okay. So this is a SBC. SBC will be given by the geotech consultant, and whatever value is going to give us, we are going to input that here. So in this way we try to design each and element. After designing those things, you are going to get the area of steel that is required. Now let us say 16 diameter you need to provide in the X direction, and the spacing has to be 125 center to center spacing, and along the Y direction you need to provide 16 diameter bar at 125 center to center spacing. So let us say this is my final steel that I'm getting. Once I get this steel, and also once I get the size, what is the size that I need to provide? 2 meter by 1.5 meter. So these things you need to remember. And what I'm going to do, I'll go to the AutoCAD model, and here I'm going to write F1 footing, and whatever size I got, I'll input it here, right? Instead of, yeah, let me make use of pen here. Yeah, let us say we got 2 meter, right? So I'm going to write here the length has to be 2 meter and the breadth has to be 1.5 meter, and the shorter side bar what we got, I'll go back to that again. Yeah, we got 16 diameter at 125 spacing along X direction, and 16 diameter along Y direction at 125 spacing, 16 at 125. So going back to the Excel, yeah, AutoCAD, and we'll, instead of T of 10 is already written here, we'll try to change that. Instead of 10, let me make it as 16 diameter, right? And even here also let me make use of 16 diameter, right? And what was the spacing given here? Spacing was 200, right? Yeah, 125 is the spacing what I'm getting. So what I'm going to do, I'll write it here as 125. I'll write here 125. 125 comes out to be 5 inches, right? Yeah, 125 comes out to be 5 inches, and 125 comes out to be 5 inches. The shorter span means it's X direction, longer span means Y direction. So this is my F1 footing. In this way, we need to prepare the footing schedule, right? I explained it for one footing. Whenever when we try to do the real projects, we'll try to do it for all the footings and we'll try to group them. So in this way, we need to do all the things. I will explain only for the footing. Similarly, we have to do a grouping for the columns as well, column reinforcement. Similarly, we have to do it for the beams as well. So for the column it will come something like this, that this much diameter of the bar, it's a C1 column, this is the size of a column. What is the reinforcement that you have to use? You have to make use of 8 bar at 8 inches center to center spacing. You have to make use of a 12 diameter bar of 6 numbers. In this way we need to prepare all these detailed drawings. Similarly, these are the schedule of a columns that we try to prepare, right? Yeah, and there are a lot of things that we need to understand, but since it's a kind of a demo class. I hope you're able to understand up to here, and you might have enjoyed the videos. So we'll see you back in the next lecture. Thank you.